A reluctor pickup produces a sinusoidal waveform, which means the direction of current flow and the polarity of the voltage output is constantly changing. The amplitude of the waveform also changes with engine speed. This means that the peak voltage produced increases with engine RPM. If your ECU has an option for turning a pull-up on or off on the trigger input, this should be set to off with a reluctor sensor. There are a couple of important points here. First, we need to be certain that the polarity of the sensor wiring is correct. A reluctor sensor has two terminals, and it will produce a signal regardless which way the sensor is wired. In its correct polarity, the waveform will look like this. If the sensor is wired backwards, the signal will look like this. The waveform is basically inverted. If the sensor is wired back to front, the engine will still run, but it will result in the timing drifting as engine RPM increases. At best, this will result in wildly inaccurate timing and poor running. In worst case scenarios, it could cause engine damage, so we need to be sure it's correct. The best way to confirm the polarity is correct is to connect an oscilloscope to the sensor and look at the waveform the ECU is receiving. This makes it very clear if the sensor is wired correctly, and you can check the waveform while cranking the engine. You don't actually need it running. Most people don't have an oscilloscope though, so another option I use is to check for timing drift once the engine's running. We'll look at this in detail in the base ignition timing module. As well as the polarity, we also need to be concerned about the arming threshold and the filtering. We deal with each of these parameters separately in this module.